Hey, yeah, yeah, I guess we're good. Uh, why are the comments turned off? Hey, I'm audible, right? Can you guys hear me?
Yeah.
Okay, fantastic. All right, let's start. Hi everyone, Nafisa here, back for day three of Evolution. For this session, I want to start off by asking a question. Um, have you ever watched the show Young Sheldon and thought that, okay, wow, imagine if that was real? Well, today in our session, you don't have to imagine because today we have the real deal. Only cooler because they're into quantum. First, please welcome Daniel Menendez, who basically lived a season of Young Sheldon by starting university at only 12 years old and graduating with high distinction in mathematics and physics at 16. And joining him is the brilliant Tanvi Gopalan. At just 11 years old, she is a science communicator we all wish we had. She can break down quantum physics so clearly she could probably give young Sheldon a run for his money at the whiteboard. So this is a really special session and I'm really looking forward to it. These two people are the trailblazers and the future of quantum. So please join me in welcoming Daniel and Tanvi. Daniel, would you like to go first?
Okay. Okay, so I'll go first. So hi everyone. Good morning. My name is Daniel Honciuc Menendez. Thank you for the invitation. It's really a privilege to be speaking here. And so about me, well, I'm 17 years old right now. I'm from Ecuador, and as you just said, I graduated from the University of Toronto in physics and mathematics. And now in September, I'm going to be starting a master's degree at Imperial College London in physics with quantum dynamics.
Tanvi, would you like to go next?
Sure. I'm Tanvi. I'm 11 years old. I'm going to seventh grade this September. And so I was born in North Bergen, which is in New Jersey, and now I live in Jersey City, so I didn't move that far away. And so one of the ways I got involved in quantum at first was a book that my parents got me called Quantum in Pictures. And well, I was just flipping through the book. It had like pictures of basic quantum concepts and then paragraphs explaining the pictures. And then it was just like really interesting. So then that just um made me think that like this is what I want to do for a living. And of course I aspire to be a quantum physicist. So I started researching on it and I was just like this is what I have my future set on, and there's no changing my mind.
Wow, amazing. Okay, so uh, back to Daniel. So, Daniel, I have a question. Most of us cannot imagine being in university at 12 years old. So, what was the most surprising or even the funniest thing you experienced being so much younger than your classmates?
So Being so much younger than my classmates, well, first, before university, before I started university at 12 years old, I did the last 2 years of high school under the International Baccalaureate. And even then, I already had classmates which were 6 years older than me, big age difference. And so but in terms of like both socially and academically, there actually really wasn't that much of a difference with in terms of like how my classmates viewed me or how the professors viewed me. There was an understanding that even though I was much younger, I was still a part of the group. And I really relied on the support of, well, my teachers in high school and my classmates in high school and then university, and with also with my professors. And it was this warming mentoring from the professors and the support which led me to continue my path in quantum. Actually, I haven't spoken about that. So I'd say that starting from first, I'd say that starting from when I was very young. I've always had interest and a curiosity for science and mathematics, and so I love reading about these subjects. I love investigating, asking questions about these subjects. I love interactive science festivals, science museums, and through all of this, a pretty big support was also my mother and my family. Um, since she really supported me with this love for with this passion I have for science. And well, as I kept going, I started taking advanced courses in these subjects. And well, this led me eventually to in 2019, at 11 years old, I was in this program. I was in this program at the Perimeter Institute for Theoretical Physics in Canada, which was for the last years of high school. And in this program was where I saw quantum science and technology for the first time as a bigger field. By then, I had already some bases in quantum physics, like principles, how does it work? But it was in this program where where I saw about how the principles of quantum physics could apply to so many other areas and so many other applications. And this really I decided then that this is what I wanted to do with my life. So I decided that I wanted to go into quantum research as a career, quantum science and technology research. And so when I went to university, I decided to study physics and math and also complement with classes from computer science. And then I started doing research experiences in quantum. And so my first research experience was actually back at the Perimeter Institute. And this was in and this was in quantum information and quantum error correction. And so these two moments, these were actually very pivotal moments. First one in 2019, and then also in when I started doing like the actual research experiences. And the reason why in the research experiences, when I started in 2022, is because it was then that I saw this well, I was reading journals all the day for quantum information, quantum error correction, whatever I was researching at that time. And that there was this entire community which I could ask questions to, I could talk about these subjects. I could talk about these fields and keep investigating. And I really, once again, it was also really a huge support from my mentors and from the professors who were supervising me. And well, this inspired me to continue with research since it was like when I was a kid, very young again, when I was researching, asking questions, reading about what back then would be like general science and math, but now was at a much higher research level. And at the same time, I would be contributing to new knowledge, and also getting paid for it since that was already a paid experience starting even at 14 years old. And so yeah, and from then I just decided to go on and continue in quantum. I had other research experiences and research projects later in quantum key distribution, quantum and yeah, with the Institute for Quantum Computing in this project for a quantum satellite, which was also with the Canadian Space Agency. And then also I continued with another research project in theoretical quantum optics with the Center for Quantum Information Quantum Control. And later at Xanadu Quantum Technologies in 2024 in a project in quantum chemistry and quantum algorithms. And also, well, there was also another research project I did, which was in dark matter detection in 2022, 2023, which was also with the University of Toronto, exploring one of my other big areas of interest, which is fundamental physics and particle physics. And for all this, I've had two research papers that have been published, one of them in American Physical Society. And but this is, of course, not the only activities I've done. Then I've also been doing research outreach, not research outreach. I've also been doing STEM outreach and quantum outreach. Um, since I was about 9, I've been doing STEM outreach in Ecuador to kids who are also very interested in these topics, and who want someone to answer the questions, just like I did back then, and they are really interested in these subjects. And then, well, after I did the summer program at Perimeter Institute in 2019. I decided to also add quantum computing to these classes, and I was 11 years old at the time. Um, and so, yeah, I just loved how I was also like sharing knowledge and how they were also getting very interested in these topics and getting inspired by these topics. But all in all, what mattered to me the most was the support I had from other people, the support I had from my family, the support I had from my professors, from my mentors, and yeah, that's how and then that's now I'm continuing a quantum as a research career. So yeah.
Amazing story. Just really, really fascinating. And yeah, I do agree that you do need a really good support system when you are so gifted. It's important that your environment is also like encouraging that instead of, suppressing that growth. So it's really nice to hear that you had this experience. And I especially appreciate the fact that you are also trying to share your knowledge with others, younger kids, that too. So it's really nice to hear that. Tanvi, would you like to go next about your own journey? Like start from the very beginning. Like how has it been for you as a young person in a field that is literally creating the future?
Well, like I was saying earlier, my first exposure to quantum would definitely be that Quantum in Pictures book. But once I started actually doing research about quantum, like recently I started a research project, like a summer research project on Dune, like the deep underground neutrino experiment and neutrinos in general. So I recently started like researching and taking notes on the standard model of particle physics too, because I'm aiming to write a research paper and finish it by the end of summer. Like write a research paper about the standard model of particle physics. And so I was doing research for that too, but um I would say that I started with the book, then I went to researching about quantum in general, and then I also went a little bit into quantum computing, like superposition states, entanglement, things like that. And I like I like to showcase these things with my podcast. I do like about one podcast episode a month. I mean, it used to be every other weekend, but um weekends are getting busier and busier, so it's now like one podcast episode every month. It's where I take like complex quantum concepts, things like I've done one on subatomic particles. That was one of the first episodes I did. And then some recent ones are I did one episode about four constants, time reversal, um one Schrodinger's most famous research paper, quantization as an eigenvalue problem. And yeah, those are, and then I recently did a podcast episode on Dune as well. So that's how I like to showcase my my like learnings and research, also through my website, which is subatomictanvi.substack.com. It's where I like write articles about quantum and then I post them there for other people to read. And yeah.
Yeah, so another thing that I wanted to mention is that Tanvi is also one of our ambassadors here at Girls in Quantum, probably the youngest one. Um, so she is, just like she mentioned that she is known as subatomic Tanvi. So um, fun question, if you could be any subatomic particle for a day, which one would you be and why?
Um probably probably the neutrino because I know I know they have like a neutral charge, but I mean they're just fascinating particles and cuz like they come in they come in three different flavors, right? Electron, muon, and tau, and their corresponding antineutrinos, and then they can exhibit neutrino oscillation when they oscillate or transform flavors in like while they're traveling, and then particle accelerators can measure them too. So neutrinos in general are just fascinating particles, so that's why I would probably be a neutrino.
Yeah, I get it. Um, Neutrinos are indeed very interesting. So, you write articles on your subatomic Tanvi website. So, what kind of feedback do you get from other kids who read your articles or watch your videos? Like, has anyone ever told you that you inspired them to start learning about science?
Well, I mean, the other day in Qvolution, the other day on I think it was Monday, somebody was like I was watching it for on the YouTube live stream, and then one of the one of the speakers, um I think at the yeah, at the opening keynote, one of the speakers were like saying that I'm an inspiration and stuff like that. So um yeah, there is that. And I mean, I had another website too, like an old domain, which was just tanvigopalan.com. That it wasn't only for quantum though. I posted like poetry, just regular um articles about things I learned. And then there were also some links to some podcast episodes. I think there was one article on physics. So that was more like a place to showcase anything I learn, not just quantum. So on that, like my friend put a comment on my website, my grandma put a comment on the website, and then they said that they really liked the posts. So that was for my old website, though I only recently started this new one, like I would say a few weeks to a month ago. So um yeah, and on my podcast I have like 17,000 listeners about on my podcast across Spotify, YouTube, and Apple Podcasts together. I would have like 17,000 listeners about, and I have like 1,500 followers, 1,500 plus followers. So yeah.
Yeah, as you can see, that Tanvi is one really popular neutrino, and I really hope that after watching this session, you guys will also check out her videos and articles if you haven't already. You're really missing out. Um, So another question that I had for Daniel. So for someone who is just starting to get curious about physics, which one piece of advice would you would give to them so that they don't get intimidated by all the complicated maths and ideas?
It's one piece I could have advice I could give to them.
Mm-hmm.
Hmm. Okay. So, first of all, and I say this for in any field in STEM that you want to go into, keep asking questions, keep investigating. Um, Through that, you'll be able to find your passions, see really what your interests are. Um, Seek out help also. Seek out mentorship. There are very good programs also now in this year's that that help students with this from even starting from primary school and and then now Girls in Quantum they also had this research they also had this program that facilitated research for that facilitated research even for middle school students and high school students. That's amazing. I love that. And the outreach efforts that Girls in Quantum has, you know. And but mentorship, you can find that either in industry or in academia or in wherever. Quantum is actually one of those fields that has, due to its interdisciplinary nature, it has a really high amount of intersections with different fields, with different and even with different career paths, right? And but you said also like what if they find a math too intimidating that for physics? Well, in that case, actually, first of all, I do want to say that there have been starting to be educational methods, even for quantum, that don't forgo the math entirely. But what they do is that they start from like a graphical and from a graphical point of view, like an analog point of view. And then as the students ease into the content in quantum, then they start learning linear algebra, not just first as simply jumping into matrices or vectors, but even just as well, just understanding these terminologies and concepts. And and really that's another thing that that's also very important. Right now, even if you're feeling a bit intimidated by the terminologies and concepts, there's always going to be something out there and someone out there who's going to want to help you understand them, and who is going to help you understand them. You should be involved in outreach activities. Search for whatever it is that you want to learn about. These days with the internet, it's become much easier than it has before. It's become much more accessible. Um, yeah, and scientists really like the young people in the future generations who are interested in the subjects. It's and they really want to teach people. That's what I've noticed. And so, yeah, there's always going to be someone who's going to be answering your questions. And you should also keep investigating on your own. That would be my advice. Don't stop asking questions.
Yeah, I really agree with everything that you say. That it's really important to just have that, just keep that habit of asking questions wherever you are, and there is always going to be that one person who is more than willing to answer your questions. Yeah, great response. So there are many people who see science as just memorizing facts and formulas in a classroom. Like, how can we learn to see it the way you do as a world of discovery and creativity? I think you have kind of answered that question as well already. But Tanvi, if you had anything to add into it, what would you say?
For the advice, I would probably say that like um if somebody wants to get started in quantum computing, then they shouldn't just like jump right into quantum computing. They should start by doing some basic research on quantum physics in general. Like some examples are if somebody researches about let's say, superposition, which is a fundamental concept in quantum physics, then they'll better understand qubits, which is a fundamental concept in quantum computing. And just like that, if they understand entanglement, then they'll better understand how quantum computers can process information really quickly because they can use entangled particles no matter how far the distance is between them. So that's one more thing. Yeah.
Yeah, that's true. You really do need to understand the foundations first before you jump into a subject like quantum computing. Um, this is a question for both of you. 10 or 20 years from now, it has been said that 10 years from now, quantum is going to make like some very revolutionary changes in the world. So 10 or 20 years from now, what do you hope to be doing in the world of quantum? You guys are still going to be really young by that time, but still, I'm just asking. I wanted to know.
Well, if I may chime in here, so let's start with right now, where we are. Well, right now we're in the phase in which, well, error correction is still being developed, fault-tolerant quantum computers are still being developed, but we've already seen many proof of concepts of applications and of algorithms and applications. By proof of concept, I mean not just theoretically, but also we've started, research groups have started to develop the algorithms, the circuits that are needed, and theoretical frameworks for even scaling up to industrial. And so in 10 to 20 years, I'll say that we'll still be working towards like large scale error corrected quantum computers, but by then we're already gonna be using more and more in day-to-day life for research purposes, smaller quantum devices for applications. So for example, for new medicines, for better materials, there are even already applications in the works and in development and even in operation, even for optimization in the financial sector. And but also in 10 to 20 years, I okay, so but also in 10 to 20 years, I do hope that the community will be much bigger. The quantum community will be much bigger. Um, with and what I love about a quantum community is that there's there are so many areas to go into. There are many yeah, there are many kinds of there's something for everyone there. And well, yeah, in 10 to 20 years, but if you're asking about me in 10 to 20 years, then I think I'll be doing is research in industry or academia. I'm thinking of specializing in quantum algorithms. Well, since I was a kid, I've always really like loved also solving puzzles. And I feel like for every new application, that's a new puzzle that's waiting to be solved and new questions that haven't even been asked yet and will be asked in the future. And so that's really what I love about research. There's always something new to go into. Um, and yeah, so I see myself working in research and industry or academia. Really more industry right now, but my opinions may change. But yeah, that would be for it for now.
No, the quantum industry is mostly still research oriented. So you really do need to like people really could use your contributions in the research industry for now. I think we're still quite far from seeing it being moved from research to actual um, applications and development. So, yeah, I really appreciate that you see yourself in doing research in the future as well. We are getting questions in a live chat. One person said that our daughter Kimaya loves your podcast, Tanvi. You are a huge inspiration to her. Keep up the amazing work. Go science. So another yes, it's a question from the same person for both Daniel and Tanvi. How will AI affect quantum? It's a question for both of you.
Well, if you're how will AI affect quantum? So in the future, if like like you said earlier, in 10 to 20 years, we're hoping the quantum is going to make some major discoveries. Like physicists who work in quantum are going to make some major discoveries. So for future quantum computers, like as soon as we can do it, for future quantum computers, we could combine the quantum technology with AI, and quantum machine learning is already a thing. So we already got started on that a little bit, and we can combine quantum with AI and just like make people's lives easier. All the hard work that physicists try to do with quantum computers, they can make that like a lot easier by combining it with AI, because there's already a lot of people who work on AI to make that better. So by combining them, we can just make people's lives easier in general.
May I also add? So, in terms of AI and quantum computing, there's, as Tanvi said, there's already a huge intersection that's already being researched and developed in quantum machine learning, for example. And one application of quantum computers right now is actually in how we train and deploy AI systems. So one of the most promising applications of quantum computers right now is quantum simulations and quantum molecule simulations. And so what this means is, to give an example, if you're trying to detect molecules in a specific sample of like soil or water or in the environment, then what you can do is you use quantum computers to simulate the molecule itself. And so this allows the AI to be trained to detect that specific molecule. And so that's one way in which it helps. It's for um, it's for generating training data. And so there are also other applications that are being developed. So, for example, even still in machine learning, there's something called quantum kernels, which are applicable to machine learning classification problems, which which they are used to map real world data into other mathematical spaces where the patterns are easier to learn for the AI models themselves. And so this enables better model performance on real world data. So, for example, in medical scans or sensor readings. And but there's also a component of AI helping quantum. So quantum computers are already notoriously fragile and noisy and difficult to control. And so there are already special types of quantum neural networks that are being trained to recognize quantum noise, suggest better error detection and correction strategies. And also reinforcement learning can also be used in order to calibrate quantum devices and optimize their performance. And so there's also predictive AI models that are used to monitor the quantum system in real time. And yeah, so there's a huge intersection both in AI helping quantum and also in quantum helping AI. That's on the research side. And yeah, it's amazing once again how we have quantum being applicable to so many different areas. That's really what I love about the field, how it's so interdisciplinary. And yeah, that's what I would say would be.
Great. Another question is from Elisa. She actually asked it earlier. I missed it. So it was, what has been the most challenging part of being involved in quantum? It's for both of you as well.
Um, the hardest part that would I mean the hardest part would also be the most enjoyable part for me, because the hardest part is probably like starting by doing doing like extensive research on the topic so that you get enough information to like if and when you showcase the concept. So researching would probably be the hardest part, but for me, along with showcasing it, it's also the most enjoyable part and the most fun part because I mean, you're choosing a concept in quantum physics. They're all fascinating, so you can so um learn about the concept and and like take notes about it and research about it. And for people who are like looking to research on quantum physics, I would recommend like when I was in 6th grade, which was only a few months ago, um I took this online an online undergrad fundamentals course on New Scientist Academy called Everyday Quantum Physics, and on that it gives you presentations, it gives you videos, it gives you little test your knowledge quizzes that you can see like check your understanding on. And once I finished it, I got the digital certificate. So for people who want to get involved with it, a course is definitely like a great starting point. And for people who prefer doing research themselves, Google created like these learning platforms called Gemini and Learnabout. So I don't know if you guys are familiar with them, but so those are like also great starting points for people who prefer researching themselves. Just like you can ask questions, and then another learning platform that Google created is Notebook LM, where you can just take like a research paper, for example, or a large study guide that's really advanced. Just upload that document into Notebook LM, and it'll create a podcast of two AI speakers speaking, and you get to choose your length, whether you want short, the normal duration, or longer. So so you can just choose. If you're in a hurry for something, you can put short. If you're just listening to it, you can put normal. And if you want like a deep dive, a deep understanding, then you can put long. So that's all. Those are all great starting points. So the hardest part would probably be researching, but these like tricks get it to be like a lot easier.
And well, going in the same vein, for my case, um, one of the things I really love about quantum is like, for example, the basic concepts, or the principles. So superposition, entanglement, or what is error correction, or quantum cryptography, QKD. Um, these are quite intuitive since they also have very good analogies that you can use to explain them. So, for example, in the case of if you're trying to explain BB84, quantum key distribution, you can just use the example of Alice and Bob, have Eve interfere, and then you can also see how when there's an interference, then the communication gets cut, but the data still is protected. And BB84 would go into more detail, but you can still use the polarizations and explain that, and it would be a good intuitive analogy. However, once you have more complex systems, so for example, if we're considering waveguides or quantum dots, or more complex and more accurate and precise qubit systems. By accurate and precise, I mean if you're introducing more environmental variables. And then you start to lose the idealness of the toy model itself. And so for these more complex systems, personally, what I love to do in those cases is use simulations. Since if you put it in a graphical format, then and in especially interactive simulations, since you can change their variables, see how changing certain parameters would change the overall performance and outcome of the system itself. Um, and it also, if you're able to code your own simulations, it also gives very good practice for when you have to code and design and develop actual other algorithms and systems. And so basically, once you actually see it visually, then it becomes more intuitive. You have that graphical sense again. And I'm not just talking about the mathematical tools, since, well, there are also mathematical tools that serve as building blocks when you're integrating different components of a complex quantum system, right? Um, and actually, in terms of resources, there are good simulations that are open source and are also free to use out there. I know that the University of St. Andrews has a thing called QVIS, the Quantum Mechanics Visualization Project. And that's more for quantum mechanics in general, but there are also good simulations on there for concepts and more complex concepts in quantum systems and in quantum technologies. Also, Tanvi, you were mentioning Google has had these courses where you could also be learning about quantum computing and also starting with decoding. There are also very good ones also offered by, for example, by IBM and Xanadu. IBM has the quantum has the Qiskit textbook. They now call it IBM Quantum Learning. But that one's a very interactive. That one is very interactive in terms of it also teaches you how to use the Qiskit library as you continue learning about quantum. Xanadu also has a similar website known as the Penny Lane Codebook, and in which they also have like an intuitive educational interface, an interactive one. You have a page open. They have you open a page which goes over the theory parts and even over the linear algebra parts, and then one where you're actually running the code, the simulations. From just the probabilistic nature of the qubits to once you're going into more complex algorithms and error correction, variation quantum eigensolvers. Those are really good resources there are. If you're just beginning, then there is also Brilliant.org has a good course in quantum computing, a good initial course in quantum computing. Um, and then there are also certain more complex, there are also more complex how to put this, more complex entry level courses that for people with a CS background. For example, Microsoft, they also have their own like initial basics in quantum computing course. They use Q Sharp, but also what I've noticed from that one is that they do much, but and their approach is much more like CS and theory focused. Um, but yeah, there are, and then apart from that, once again, there's always YouTube. There's always going to be someone who wants to who's going to be explaining these concepts, who's going to be answering your questions, and but yeah, that would be what I would say. Once you're going to more complex systems, there's simulations. There are interactive programs that are available. Interactive programs you even yourself can make if you know the details for how the system works. And yeah, that would be like how I manage these challenges. Yeah.
Yeah, great responses from both of you. So I have one interesting question in the live chat. Uh, how can quantum technology help solve problems in Africa?
In what you said?
In Africa.
In Africa?
Yeah, I think the person who asked this question is from that country, so they're just asking how quantum technology can help solve problems in the context of Africa.
Um, I mean, in general, quantum in general, quantum can help solve a lot of problems. Like for example, in quantum computing, there's the quantum computers need the temperature of a Bose-Einstein condensate to actually function. That's like 0 Kelvin or absolute zero. Like this is the temperature where particles that are relentlessly zipping around the room start to like slow down and then eventually clump together. And that's the temperature that a quantum computer needs to not do anything crazy, just to like normally function. So they need like an extreme cold temperature to function. So as we like keep contributing to quantum, and if and when physicists keep on like making new discoveries, then the like this problem is going to be resolved. It'll But like quantum computers aren't meant to be just sold in stores. It's not like you can just buy one and then work on it and watch YouTube on it. That's not what quantum computers are meant for. They're meant to be used as special purpose computers. Like they're meant to be used as special purpose computers to do things that a normal computer isn't capable of doing. Like quantum computers, if you just like quantum computers aren't meant to be used to solve Pythagoras equations. A normal computer can do that, but quantum computers aren't, like they're not meant for doing these kind of things. But as physics, or as quantum physics rather, keeps evolving and revolutionizing, then this could be possible. But it's not only about them being sold in stores. It's about the field as a whole, to like enhance it and figure out more about it. But there's never going to be a moment where you say, I know everything about quantum, because the like you'll get questioned, and then the questions lead to answers, which lead to more questions, and so on and so forth. So you'll never be done with like you'll never be done learning about quantum.
Yeah,
Yeah,
that's
you're
true. Y- Daniel, do you have anything to add into it? Yeah.
What you said at the end, that you're never gonna like end learning about quantum, that is that is the beauty of this field, the beauty of research, that there are always new things to discover, there are always new things you can apply quantum to. And though as you said, also like quantum, it's not really for like personal computer purposes. It's for solving problems that classical computers aren't able to. You said that really well. And but yeah, still, quantum still is very interdisciplinary, has so many applications, medicine and finance. There are already climate applications that have started to be developed also. And so quantum technology, it has all these components where it can solve problems. It's another it's another new revolution in technology that we have. And so, yeah, when it's to and so it has a huge capability and huge potential to be used for good and to be used to solve problems in the world. So, um, that's also really what I love about quantum. Once again, yeah.
Um, there was another question from Elisa. So, if you were to go back to where you first started learning about quantum, would you change anything?
Okay, so I can start with this. When I went back to start learning about quantum, would I change anything? Then, say, starting in 2019, when I had like first lecture in this, I would say get involved in research from the beginning, from where especially if you want to go into a career in this, read more journals, because it's going to help you, like, stay updated on what's new in quantum. Through there are pretty good. Xanadu, I know, has a quarterly has a quarterly like journal, best journals of the previous months, newsletter. But you should really be reading into the journals of what you want to go into, of what you want to research, to see what are the new technologies, what are the new developments. But also, if you're starting, journals can also be a good place to begin your quantum journey, because as you encounter the terminology, and you're going to want to look it up, investigate more. What does it mean? What are they trying to talk about in the journal? What are the problems they're trying to solve? What are the results? So that will really help you if that will really help you if you want to go into research in that area. But then also, this I'm going to say in general, more mentorship. That would be something I'd say to myself, like seek out mentors a lot more often, seek out help. And speaking of mentorships, I really want to give special recognition to a mentor that I really that been one of my most important mentors in quantum computing, Professor Raymond Laflamme. He's one of the pioneers of quantum information, quantum error correction. And in 2019, when I was at this summer program at Perimeter Institute, he was the one who gave the master lecture on quantum computing that really inspired me to go into this area, open my eyes to how the principles of quantum physics can be applied to once again to all these different fields. And also in 2022, when I started my research experiences, he was my supervisor actually at Perimeter Institute. And he was always very open with whatever question that I want to ask him. He was always open for a chat about quantum or about anything else. And another thing I would say is that I would have really loved to tell him more about how he inspired me. Yes, about and not just me, but also the future generations. He is a he is a really big advocate for quantum, and yeah, he's been one of my biggest mentors in all this time. He recently passed away. And so, yeah, I'd really have loved to tell him more about how he's been inspiring me, yeah, to continue on this journey.
Yeah, Professor Raymond would be so happy to see you progressing in this field so nicely. I mean, he would be really happy to see everything that you're doing in this field. Um, it's really nice to hear that how he has inspired you. I think this also covers the question that Elisa had, that who are your role models? Tanvi, I don't think you explicitly said anything about your role model. So would you like to add in?
Sure. So I mean, I have a lot of role models to be honest, but like um probably other physicists like Albert Einstein, Erwin Schrödinger. Erwin Schrödinger was actually like as a young professional, I would say he contributed to quantum physics with his research paper, um quantization as an eigenvalue problem. He published it in 1926, and that's how he actually like contributed himself to the field. He also wrote some books. He wrote other research papers. When I was in 6th grade, we had to do a project on a specific hero, and I chose him. So I had to do research about him in that too. And then on one of those big trifold posters, we had to present. We had to present that to. We had like a table, and people would come around walking, and then we would have to present to them. And I was like talking nonstop for 2 hours. So my two main role models would probably be Albert Einstein and Erwin Schrödinger. Also Leon Letterman, because he was part of the like foundational research on the Higgs boson and the Higgs field. So yeah.
Einstein is a really interesting choice, given that he had so many doubts about quantum mechanics. So yeah, it's really nice to hear that Einstein is your role model. Um, I think we have covered all the questions that we had. There was one question that was asking Tanvi what her what the name of our podcast is. If you could drop it in the Discord server, that would be great, so that people who missed it, they could also see it there. Um, okay, I guess we have neared the end of the session. If you guys have anything else to add, please go ahead. Feel free to say anything to the participants, anything. That would be great.
Well, I'm not on my computer right now, so I don't have the Discord chat open. So for now, I'll
Mhm.
just say that the name of my podcast is Quantum Physics for Kids. It's available on Spotify, Apple Podcasts, and YouTube, so you can find it wherever. And yeah, just listen to it, and I hope you learn a lot from it.
Well, in my case, what I would say is the usual, like, continue with your dreams, be persistent in what you want to do. Don't let anyone or anything stop you. It's something yeah. And keep asking questions. Just keep asking questions. Keep investigating what you love. Keep investigating your passions. And yeah, that's my final advice I would give.
Thank you, Daniel. Thank you, Tanvi. What an incredible session. I think what Daniel and Tanvi have given us today is more than just a glimpse into their journeys. It is a new perspective. And they have shown us that science isn't just a subject in a textbook. It could be a story, it could be a conversation, it could be an adventure. You can start at any age. So they are the role models for the accumulation generation in a way, and proving that passion, not permission, is what truly matters. So to everyone watching, I hope you leave this session asking your own questions, like Daniel keeps emphasizing, and chasing your own curiosity. Again, Daniel, Tanvi, thank you so much for leading the way. We cannot wait to see the worlds you will build. Thank you so much.
Thank you. Thank you so much.
Thanks, guys. Bye.
Bye bye.